Welcome. I'm Professor Richard Tamboro, Daytona State College. I will be demonstrating a traditional hypothesis test method for a single population. Let's take a look at the problem that we're presented with. We're going to test the claim that the number of dogs per household is equal to 1.4. To test this claim, data has to be gathered, and in this study, data was gathered from a number of households, and a sample mean and sample standard deviation were found. The sample mean in this case is 1.6 dogs per household with a standard deviation of 0.8 and 36 households sampled. Okay, in this problem, the population standard deviation is unknown and the sample standard deviation is known. Whenever you have that condition, you use a t-distribution hypothesis test statistic formula. It requires that we find a degree of freedom, which is n minus 1. So 36 minus 1 is 35. Okay, to continue, we are given a significance level of 0.10, and we will need to look up a critical value. The critical value for this hypothesis test is based on the test to claim of equal to 1.4. So we'll start equal to 1.4. The complement to equal is not equal. So what we have is a two-tail hypothesis test. It's important to acknowledge the two-tail hypothesis test. When you look up your critical value, that's where you start. Whether you have a one or two tail determines a lot about what your critical value will be. So because we have a two-tail, we need a two-tail critical value for a 0.10 with degrees of freedom of 35. In this case, we have a critical value of plus minus, that's the two-tail, 1.306. Okay, so now that I've had my critical value, I can set up the graph and the rejection region. So because it's two tails, we have a rejection region on the left and the right. Population mean is in the middle. The alpha is divided in half, and we'll put 5% in each tail. Okay, so the 0.10 is 0.5 on the left, 0.5 on the right. Now I'll add my critical value. This defines the rejection region. This is a t-distribution graph, so I'll put a t to label the line. Okay, next step is to apply the test statistic formula. So let's try that out. First, I'll start with the sample mean. If you're putting this into your calculator, then these parentheses are important, so don't ignore the parentheses. Okay. All right, so make sure you look closely at the parentheses. They're needed. You need one for the numerator, a set for the denominator, and then some calculators, most, put a parenthesis under a square root. Okay, now when we put that in the calculator, or maybe you're using a piece of software, you'll get a test statistic of 3.000. 3 decimal places is typical. Let's add that to our list. And now we'll plot the 3.00 standard deviations. This is standard deviations. So I start at 0 and I go over 3 standard deviations. So that'll put me right here at the end of the bell curve. So my test statistic is right here. It's clearly in the rejection region. So we make the conclusion. There's only two conclusions. Either reject the null hypothesis, which is what we have in this case, or fail to reject the null hypothesis. No other conclusions. Those are the two conclusions. So in this case, we reject H sub 0. Anytime you reject, you have a possibility of error type 1. So error type 1 is just a designation for when you reject the null hypothesis, there's a certain probability that it's true. If you were to draw a conclusion erroneously about the null, that would be an error type 1. So reject is error type 1, fail to reject is error type 2. Okay, so what can we say about our conclusion? Our claim is that there's 2 dogs per household. The randomly selected surveys didn't provide sufficient evidence to support the claim. So we are not supporting the claim that there are 1.4 dogs per household because the test statistic landed in the rejection region. Thank you very much.